Hey, welcome to our video where we'll be doing the density lab with you. If you haven't already, please pause the video and print the lab sheet. Looks like this. The first page you get the procedure and then the data chart, and then on the following pages are the calculations. Also, it would be worth your time to watch the pre-lab screencast, which will help you better understand not only how to collect this data, but also the theory behind the lab that we're doing, and also we modeled a little bit the calculations. So as you can see from the procedure, we're going to be finding the density of 3 liquids and 2 solids. The 3 liquids that we're going to be doing are tap water, distilled water, and then an alcohol called ethanol. And then the solids that we'll be doing are aluminum and also zinc. So to get started, as it says in the instructions, the first thing that we need to do is weigh an empty graduated cylinder. To do that, we simply hit re0, place the graduated cylinder on the balance, and that is the mass of our empty graduated cylinder. If you need to pause the video to record that, go ahead and do that now. Now that we have the mass of the empty graduated cylinder, we need to now put some water, this will be tap water, in the graduated cylinder. Now, it does not matter how much water we use because the density of water is the same regardless of amount. So we're going to get a rather large sample simply so that we can spread out any error that we might have over a larger sample. So now that we've got our sample of distilled water, or I'm sorry, of tap water, the next thing that we will do is measure the volume of that sample of tap water. We'll zoom in then to the graduated cylinder, and using the skills that you have learned in the last couple weeks, please then record the volume of the tap water in the graduated cylinder. Now that we're done with that, we simply need to come back, re-0 the balance one more time, place the graduated cylinder with the water on the balance, and from there you can record the final mass, which is all of the data that you need in order to figure out the mass and therefore the density. So we're now done with our tap water trial. We will now do the same thing with distilled water. It is important that we reweigh the balance again. Its empty mass will not be the same because now it's a little bit wet. So record that as the mass of the graduated cylinder for distilled water. Now we will get a sample of distilled water. As you learned in the pre-lab discussion, distilled water is water without the minerals in it, and got a little more than the scale, so we'll stop there. Again, take a second and record the volume of that sample of distilled water. If you weren't able to do that, you can always back up and pause the video. And then finally, we will re-0 one more time, place the graduated cylinder on the balance. And we're now done with the second set of trials where we now have the information we need for distilled water. The last one we need to do then is the ethanol. Again, we will re-0. Oops, didn't quite re-0 there. Re-0 the balance. Again, measuring the mass of the graduated cylinder empty. And this time we'll be adding ethanol. Ethanol is actually the alcohol that we use for hand sanitizer. And we will get a sample of ethanol. Remember that when you do this, you want to palm the lid, and we will dispense an amount of ethanol. I think we can go a little bit more. We'll stop there. Again, following the instructions, we will read the volume of that ethanol sample. And then we will re-0 the balance one more time, and we will read the mass of the graduated cylinder plus the ethanol. Okay, so now we're done with our 3 liquids. We will actually collect our ethanol in a waste ethanol beaker. That does not go down the drain. And at this point, we're now ready to do our 2 solids. As you know from the pre-lab discussion, the way that we handle the solids are a little bit different. The first solid that we will use is zinc. As you understand from the pre-lab conversation, we will use more than one piece of zinc. Again, large samples decrease error. And we will place these pieces of zinc on the balance. That then is the mass of our metal. From here then, to find the volume, we will use water displacement. To do that, we will get some water in our graduated cylinder. We will measure the volume of that water. And then we'll carefully slide the zinc that we weighed previously into the graduated cylinder. Get the air bubbles out. And we will then measure the volume of the zinc in the water. Okay, now it's going to take us just a second to clean this up. There is a beaker where we will collect the wet zinc. We will pour this off, collecting the metal, placing then the metal in the wet zinc container, and we will now carry out the same procedure with aluminum. So we'll re-zero the balance. We will get 8 or 10 maybe pieces of aluminum, weighing those pieces of aluminum. We then once again place water in a graduated cylinder. We will read the volume of the water. And following that, we will slide the aluminum, missed a piece, slide the aluminum into the water, and recording the volume of the water and the aluminum. That is actually the last piece of data that we need to complete the lab. We'll clean this up after we stop shooting. Your job now is to do the calculations. Please know that there is a sample of the first calculation there on our website, and you're welcome to access that. You'll notice that the accepted values that you need for the densities are given in the percent error section of each calculation. Then you'll also notice that for zinc and aluminum, the accepted values for their densities we will actually take off of a periodic table. Now, if you're watching this video at home, there is the chance that you do not have a periodic table. All that you need to do is Google density of zinc, density of aluminum. Make sure that those units are given to you in grams per centimeter cubed or grams per milliliter, and you can look those accepted values up off the off of the internet. There are some conclusion questions on the back. So you should have all the information that you need to finish this lab up, and please let us know if you have questions.